Welcome to our video on reverse bias PN junction diodes. In this lesson, we'll understand what happens when we apply a reverse bias voltage to a PN junction diode. Before discussing reverse bias, let's quickly review what a PN junction diode is. A PN junction is formed when a P-type semiconductor material is joined with an N-type semiconductor material. P-type materials have an abundance of holes as majority carriers, while N-type materials have an abundance of free electrons as majority carriers. At the junction between these two materials, a depletion region forms due to the diffusion of charge carriers. Free electrons from the N side diffuse across the junction into the P side, combining with holes near the junction. Similarly, holes from the P side diffuse into the N side, combining with electrons. This diffusion leaves behind immobile charged ions on both sides of the junction, creating an electric field that eventually stops further diffusion. Now, let's understand what happens in a reverse bias configuration. In reverse bias, we connect the positive terminal of the battery to the N-type material and the negative terminal to the P-type material. This bias configuration is opposite to the forward bias, where the P side would be connected to the positive terminal and N side to the negative terminal. When reverse bias is applied, the depletion region widens. This happens because holes in the P-type material are attracted to the negative battery terminal, and electrons in the N-type material are attracted to the positive battery terminal. This pulls majority carriers away from the junction, leaving behind more immobile ions and thus widening the depletion region. The widened depletion region creates a stronger electric field and a larger potential barrier. This increased barrier makes it extremely difficult for the majority carriers to overcome and cross the junction. As a result, almost no current flows through the diode. However, if the reverse bias voltage becomes too high, reaching what's called the breakdown voltage, the electric field becomes strong enough to break covalent bonds and create electron-hole pairs, leading to a sudden increase in current. Let's summarize the key characteristics of a reverse-biased PN junction diode. First, the depletion region widens. Second, the potential barrier increases. Third, only a very small current flows, known as the reverse saturation current. Fourth, reverse bias is used in applications like photodiodes and varactor diodes. Finally, exceeding the breakdown voltage can permanently damage the diode unless it's specifically designed for operation in breakdown, like a Zener diode. Understanding reverse bias operation is crucial for electronics design, as it determines the behavior of diodes in circuits where they may be subjected to voltages of either polarity. Thank you for watching this video on reverse biased PN junction diodes.